Okay, create a new project in CubeMX, and I'll be using the F756ZG, and I'll choose an oscillator for the board. Then I'll choose the serial wire for debug, and I'll enable the Ethernet, choose the RMI interface, then enable the Ethernet interrupt. Then obviously you have to change the Ethernet pins because ST doesn't assign them properly, so select PG1 as Ethernet TX enabled and PG13 as Ethernet TX D0. Let me find over here. Now enable the UART3 for debugging, which is connected to PD8 and PD9. And that's basically it. Go to, obviously, we have a clock issue, so I'll run the clock configuration resolver. And so select the CMake as the tool for generating the code, choose a name for the project, Mongoose TCP Client, and for this project you'll need also the Mongoose library. You can find it on the GitHub. I'll leave the link in the description. Basically you need the mongoose.c and mongoose.h. I've already downloaded them. So generate the code. Then I'll open VS Code, and then I'll go to the ST extension because I'll be using the VS Code extension for STM32. Then the code has been generated, close it, and now I have to import the CMake project. Click on import CMake project, then I'll choose the project, which is this one. I'll select it, select import project, open in this window. Now I will include the select debug over here, close everything out, and I'll include the libraries. So go to core, source and include, and I'll copy the C file in the source directory and the header file in the inc directory. I have already made a video on how to switch to VS Code for STM32 development. You can go and check that out if you don't understand what I'm doing here. Now I need to go to CMake lists and add the path to the external library. So go here to target sources and add the path to the source file. C or src, and then mongoose.c, as well as the include directory, which will be /inc, and that's basically it. Now I need to create a mongoose config.h. I have already made a video on how to set up Mongoose, so I won't explain that again. So go here, new file, mongoose config.h. So I'll define the architecture. Which is basically the C library used by the Mongoose, obviously. Now I need to enable the TCP IP stack from Mongoose. Now I need to enable the minis function. It's just like a whole get tick function, but meant for Mongoose. Define ng enable custom minis to 1. Now I need to enable the driver for STM32 because the code that I'm showing you here can work with any other microcontroller vendor, for instance ESP32. So define ng enable driver STM32 F1, and then I'll need to set the network data, such as the IP, gateway, and the mask. So I'll write define ng enable, no, actually ng TCP IP, and it will be ng IPv4 because it has to convert it to the network byte order. So I'll write 192.168.137, for instance, 22, and then I copy it, and then do that for the mask as well, and the gateway. The gateway will be the IP of the USB to Ethernet converter, which is 1, and the gateway, actually, wait, the mask, yeah, mask will be 255.255, and yep. Zero. So that's basically it for the config file. Go to main.c and set up the Mongoose manager. Obviously I have to include the mongoose.h, as well as the mongoose config.h. Then I'll set up the connection manager. So right here, struct ng ngr init address of mgr. Actually, I'll set the log level to debug. So ng log set gll debug. To create the TCP client, we will need to add a timer handler, which will basically trigger once every second, and it will send out some data to the server. So I'll write to the connection structure, which will keep track of the TCP client connection. So I write here struct ng connection call equal null, and then I'll add the handler function. So ng timer add address of mgr, then the period will be 1 second, then the flags, which will be ng timer run now, out with ng timer repeat, such that we want to trigger the timer handler immediately, and then we have the timer function, and then the additional parameter, which will be the address of the manager, because we will need it later on. Here we write the polling function, which basically keeps track of the incoming events related to the network. Address of mgr, and then 100 will be the period in milliseconds. Now we'll add the timer handler. So go to user code begin 0, and actually I should have written this in the private variable section like this. And also we'll need the connected variable, connected, which will be set to 1 when the board will be connected to the TCP server. So I'll set it to false, and here I'll add the timer handler, set it void timer function void arg, and also the event handler. So I write here the static void ev handler. Then the parameters are the mg connection. I leave the Codium extension complete the code for me. Actually, we don't need this parameter, so I leave it like this. Now we'll need to take the manager structure as a local variable, so I write struct mgo like this, mgr mgr equal, yeah, like this. I'll take the argument because, as I said, the address of the manager, it is passed over here, and then now this manager points to another structure which basically takes care of whether the client is connected to the server itself. So I write like this, struct mgr, because we will need this structure in order to let us know if the client has connected to the server or not. So I write struct mg TCP IP TCP IP, and it is not like this, it is, we have to typecast it, and then will be mgr, then the priv variable, like this. In order to configure the board as a TCP client, we have to make sure that the network is up beforehand. So I write, so the TCP IP has a variable which tells us if the network is up or down. So I write like this, if g TCP IP slash state equal mg TCP IP state ready, and connected is equal to 0. So we'll try to connect this time. I'll write mg connect, and here we'll need to pass the mgr. Then I'll pass the URL, which will be TCP, and then the IP of the USB to the Ethernet converter. So it will, in my case, it will be 192.168.137.1, and I'll be sending a request on port 80, like this. Then we'll need the address of the event handler, and then no parameters, no additional parameters. Now we need to assign this mgconnect to the connection structure con, because we'll need it later on. Now well, I've done a mistake over here. I have to make sure that the connection structure is not null. So I write like con not equal to null. And then I'll say this, we'll have to connect. And I'll set connected variable to 1. Then I'll check if the client is connected. So if connected equal 1, and simply I'll send something on the Ethernet port. So for instance, mg send then a connection structure, and then the string that we want to send. So for instance, sending from TCP client, and then the length, which will be this one. Obviously I have to include the string.h. Oh, it's actually included already, and that's basically it. Now I'll simply add something else, such that whenever I receive something from the server, I will get the data and I'll respond to it. So if the event ID equal mg event read, meaning that the server has sent us some data, I will basically read out the data and respond to it. So basically, the way Mongoose works is like for every connection, that connection has a receive buffer and a transmit buffer, and the received data is stored in the received buffer, and the received data is stored in the received buffer, and the transmitted data is stored in the transmit buffer, and then it is sent over the network. So I write here mg send this con received from server, and then I'll say the length, and now I'll simply send back the response that we've got. So I write mg send con, and then the data from the receive buffer. So con, actually no, I should have, yeah, it's correct. It was the variable name. Yeah, con receive dot buffer, and then the length of the buffer. Now we have to set the length to 0 because we have to let the Mongoose know. We have to let the Mongoose library know that we consume the data. So I write con receive dot length equal 0. So that's basically it. I will build the program, and we get an error, and have some errors here. It should have been mg TCP IP IF for the interface, as well as here I should have written equal, such that we need to connect only once. Then I have to write here gmgr, and here it should be connected. So I'll build the program again, and we get an error. Oh, it's actually with 3 ends. I'll build it again. Terminal. Oh, actually, let me see. I think I need to rename the. No, yeah, I should have added the mg minutes function, which keeps track of the time. So uint64t mg minutes void return hard get tick, like this, and then I have to rename the Ethernet IRQ because the Mongoose has the IRQ with the same name, like this. Build it. We no longer get errors. Now I flash the program, so go to terminal, run task, and then build flash. Continue without scanning the task output. And open real term and see what we get on the terminal. My bad, I forgot to add the retargeting function. So I'll have to go to syscalls.c and copy the write function so that I can print something on the terminal. So go to main.c and add this function and remove this and just send data via UART here. HAL UART transmit, and then UART3, as well as the PTR and the length, and here the delay of 1 second. Now I'll build it again, and I get an error. Wait, I didn't enable the UART. I think I didn't enable the UART, so I'll go back to the Kubernetes generator and I go to UART3 and set the asynchronous, and I generate the code again. Oh, actually, no. Actually, I have to enable the TX over here, like this. I'll generate the code, close it, and I'll open VS Code again. And it's been added. Now I'll build the program. Oh, actually I have to rename the Ethernet handler again, and I'll build it. Yep, let's go to terminal, run task, build plus flash, continue without scanning. I'll open real term. Let's see what we get on the terminal. And let's wait. And I think I've done something wrong here. I added the connected in the if statement over here. I have to remove it and put it over here such that it sends it every 1 second. So I'll build the program again and I run it. Build plus flash, continue without scanning the output. I'll open real term, clear it, and then I'll open the Hercules. Yep. And I'll open the TCP server. Listen, I'll reset the baud. And as you can see, we're getting the data. Now I'll send something like Mongoose is here. As you can see, it says Mongoose is here. I should have added the new line character. By the way, if you're interested in learning more about embedded systems, I have a free community related about this. We are hosting Q&A calls. You can write everything related to embedded software in the chat. We will help you, and you can connect with like-minded individuals. We are already 15 members. You'll have the link in the description. So that's basically it. Also, if you want to add UDP, you only need to change 3 letters. I mean, if you want to configure it as a UDP client, so bear with me 10 more seconds. So just change the URL to UDP and build it. Run terminal, run task, build flash, continue without scanning. I'll clean everything out. I'll go to UDP, I press listen. Let's see if we get something. And we don't. I think it's something related to the server. So I'll open Wireshark, and see if I get something. Wireshark. So the Ethernet port is STM32 Ethernet. I'll open it, and we're getting something. As you can see, this is the string sending from TCP client. And if I open the payload, no, actually over here, it says port 80. So basically it's the UDP client is working, but there's something wrong with the UDP client, UDP server.